u sin theta divided by g, where our g is the acceleration due to gravity and our u is the initial velocity and the theta is the angle of projection. Theta is the angle of projection. So what this means is that the projectile, the time taken, what you are calculating is the time taken for it to move from the point at which it was projected to the point where it first landed. That is from this point to this point. The total time frame taken, that's what you calculate. And the time to reach the maximum height, the time taken for projectile to reach half the distance of the total journey. Here we have there's a maximum height here. So the time taken for the projectile or the object projected to reach this height is a time taken to its maximum height. That is, if they ask you find time taken for a social projectile to reach the maximum height, this is what you are calculating, and the formula is u sin theta divided by g. Why? Because this is basically half the journey, and you dividing half the journey by 2, so we cancel the 2 here for the total journey. So let's proceed. Like I said earlier, we have maximum height. And the maximum height is a point at which there is no vertical motion. That is, no vertical velocity is completely at rest. So the maximum height attained is the highest vertical distance attained by the projectile as measured from the horizontal projectile plane. An object thrown at an angle of 90 degrees will reach a very great height depending on the force applied. That is, when you project an object at an angle of 90 degrees, it reaches a very, very high place compared to when you project it at another angle, let's say 45 or 60. It won't reach a great height. But when you project it vertically, it will definitely reach a greater height depending on the force you use. If you apply a greater force, it reaches a greater height. And if you apply a lesser force, it reaches a more medium height. So, like I said earlier, the maximum height is this point where there is no vertical motion and there is no end velocity, is completely at rest before it continues its motion downward again. So let's proceed. We have range and maximum range. Range is defined as the horizontal distance from the point of projection to the point where the projectile hits the projectile plane again. The formula is given as u squared times 2 theta divided by g. Now, what is range? The range is the total distance covered. That is, this distance covered here is the range. That is how far your projectile went. Okay, so when they ask you for range, they're asking distance from the point at which it was projected at first to the point at which it landed. Then you calculate for the distance. Yeah, range is similar to the distance covered by the projectile from the point of projection. And maximum range is attained when the projectile is projected at an angle of 45 degrees. That is, if you project, let's say this is my angle 45. If I project an object at this kind of angle, it will reach a very far place. Earlier I said maximum height is when you project it at angle 90. Yeah, so angle 90 is for maximum height, and angle 45 is when you want your projectile to reach a very far distance. In other words, maximum range. Now we have some work examples here. So said a ball is kicked with an initial velocity of 12 meters per second at an angle of 50 degrees to the horizontal. A. How long will the ball stay in the air? Assume it strikes the ground at the same height it was launched. B. How far will the ball go before it hits the ground? C. What will be the maximum height of the ball? Solution. Our initial velocity u was 12 meters per second, and theta is 50 degrees, and we can assume that acceleration of gravity is 10, or we can as well decide to use 9.8, so we only have a meager difference. Now, earlier on I said we'll use the formula for time of flight is 2u sin theta divided by g. Once you impute your values, where your u is 12, the section here means multiplication, so 2 times 12 times 50. 2 times 12 will give us 24. Sin 50 is approximately 0.766. Divided by 10, you get 24 times 0.766 is 18.38. Divided by 10, you have 1.838 seconds, which is approximately 1.84 seconds. If you decide to use 9.8 as your acceleration to gravity, you can just say 24 times 0.766 all divided by 9.8. You'll get 1.875, which is approximately 1.88. So the difference there is 0.04 seconds, which is negligible. Now your range, the formula for range is square sin 2 theta divided by g. You put in your value, we all know that the u is 12. 12 square is 144. Then sin 2 theta is sin 2 times 50 is 100, sin 100, divided by your acceleration to gravity 10, you get 144 times sin 100 is 0.9848, and it gets 144 times 141.8 divided by 10, you'd have 14.18 meter approximately. Once again, if you decide to use 9.8 as your acceleration due to gravity, you'd have 14.47 approximately, and which is 14.5, and this here is 14. You place it in one decimal place, 14.2, and we'll have a difference of 0.3 meter, which is negligible also. And your maximum height is u square sin square theta divided by 2g. This is where it all gets tricky. What it means by sin square theta is you applying the trigonometric function twice. That is multiplying it by itself before you impute the final answer. So we'll have u square as 12 times 12 for 144. Sin square theta as sin 50 times sin 50. Then we'd have 144 multiplied by 0.766 multiplied by 0.766, all divided by 20 because you're multiplying your acceleration's gravity by 2. So you'd have 84.5 all divided by 20. Then our final answer will be 4.23 meter. So what they are trying to say here is that the time of flight of the projectile was 1.84 seconds. The range, that is the distance it covered, was 14.18 meter, and the maximum height it reached before moving downward again was 4.23 meter. So there we have it. Solved one example, and you should try to solve more. Practice makes perfect, like they say. So proceed to the next slide. Now, here's a bonus question for you. A golf ball is hit at a cliff 150 meter away with an initial velocity of 70 meter per second at an angle of 40 degrees to the horizontal. How long will it take for the ball to hit the cliff? At what height did the ball strike the cliff? Let me know your answer in the comment section, or just solve it somewhere and send it to our community. Now, in this lesson, I hope you can state the definition